recording. All right. Family of functions. Long story short, you don't have to copy this because I already gave you a handout. Okay? But if you want to add a little note to it as we go, you can. Family of functions. Let's pretend I have this. Let's say that's a -4, that's a -1, that's a 3, and that is a 6. Okay. And that's pretty much it. If I gave you these 4 points and I told you it was, well, you know what? I didn't tell you anything else. What can you tell me about this curve? Let's make the assumption that they're all order 1. What could this shape look like? Really rough. Go ahead. Yeah, so something like this, right? I don't know if that looks, what that might actually look like. All I know is it goes through all 4 points. But what you drew in your head might not be what someone else drew in their head. What about someone else? Yep. Yeah, it could be upside down. Absolutely. Or something like that. Someone else? Did they have something else in their heads? Did someone have something like this in their heads? Right? You could have had something even more of a stretch, right? It could have a huge stretch and go all the way up to a point you can't even see it, and then come back down. And then all I'm trying to get at is an x-intercept isn't necessarily enough, but all of these curves that I've drawn have something similar between them. Long story short, if I told you to give me a possible equation, a possible function for this, what would you write? F of x is, what do you know about this curve? Jamie? Yep. So let's keep that, I'll do that in a second. X. -3 and x -6. Absolutely. So all 4 of these curves that I've drawn, this is something that they have in common. Every single one. So what is the one thing that's causing such a big difference between the 4? The A value, the stretch. So this is what we would call, right? I'm just going to type it up, right? This would be an equation for this family of functions. That's what we would call that. So by definition, a family of functions simply means, I'm dumbing it down here, equations or curves that have the same x-intercepts. That's a family of functions. Right, so that's a family, right? They all have the same last name or something. I don't know what you want to call it. Whatever is a family. Like you're born in the same neighborhood, so now you're a family. I don't know. Like if you're living in Fast and Furious, family means what? I don't know. If you grew up with more what is that? What's the one with Lilo and Stitch and whatever, right? What does family mean? Everyone has a different definition of family, I'm sure. In math, family simply means all the x-intercepts are the same. Yes. So when I say give me an equation for a family of functions, right? You don't know which actual member of the family it is. So you leave it ambiguous, you leave it blank. This is an equation for a family of functions. And then in the following question on your sheet, it'll ask you something along the lines of, find an equation for a member of the family that does this. So I'll write the next bit. If you want to put a little note to it, say, to identify a member of, identify an equation for a member of this family, you need one thing. No. Yes. Nope. I just randomly, this is just a talk, this is just a discussion. Yeah. So an equation for this family of functions, to identify an equation for a member, a single member of this family, you need a single point. Good. You need an XY. It could be it could be a Y-intercept, it could be a random point. But for the sake of argument, let's talk about the Y-intercept. Okay. The Y-intercept for the solid dark line is here. The Y-intercept for the red line is here. The Y-intercept for the gray line is here, and the Y-intercept for the blue line is way up there. As you can see, although all four of them pass through the same X-intercepts, where they go past that is all different. When X equals -3, the black line could be here, the blue line is here, the red line is up here, the gray line is over there, right? If I ask for what X equals -2, all four will have a different Y value, so on and so forth. So that's basically it. So going through this sheet, I'm going to ask you, hey, here are some roots, here are some clues, give me an equation. It's basically like detective work. And that's the end of our lesson today. Yep. So we're going to try some practice. I'm going to do it in reverse. If you look at the example 3, there's a graph and you go backwards, right? Here we go. I am going to share screen of this. So yes, you have done something like this even in chapter 1, but we never explicitly talked about it, but now we have. Here we go. Determine an equation for this family of functions. It's just a cubic function. So I know it's going to be something to the x to the power of 3, or it's going to have 3 different brackets, right? Hopefully it has 3 different brackets, not always. I'll cross that out. Determine an equation for this family. So, go ahead. Yep. Yep. X minus 3. Good. That's good. That's all it is. But of course. So X plus 2. That is a plus. Sorry. There. There. Okay. Question or? Essentially. So when X equals 2, the Y value equals 1. So you could plug in 2 here and write f of 2. But I know what you're doing, right? So all you have to do is give me the Y value is a 1. And the X value is a 2, 2, and 2. I'm too lazy to write it all out. So I will do my mental math. You can do that too on a test, okay? 2 plus 2 is 4. 2 minus 1 is 1. And 2 minus 3 is -1. So 1 is equal to 8 times -4. That's it. At that point, from here, you can copy this down or you can review it. I'm going to encourage everyone to take a chance with example 3. It's basically the exact same style of question, but instead of telling you what the x-intercepts are, it gives you a graph. And it gives you a lot of information just from the shape. Oh, I see. Give me a sec. I keep forgetting that not all of it is visible. Just give me a second while you work on that. I need to make sure I fixed attendance. Ooh. Ethan, Ethan? Ethan?
Yeah.
It is 9:31 when I edited the attendance.
Yeah.
It was supposed to, I think, if it's not done by 9:30 or 9:45, an automated something goes out. So if you got a call at home, just be like, Mr. Kim messed up, okay? Okay. Got it. Yes. Mm-hmm. 3 or 5 or 7, but 3 is acceptable. It is definitely odd. Okay, I like to jump to example 3. And see if you can take this picture, take this graph, and word it in the same way as you see here. What are the zeros? Determine the family, and then identify the point. We will do example 2 soon, after this one. Yes and no. You'll see how the A value changes based on that. So bear with me. Okay. So taking a look at example 3, the reason why I give you something like this is because if I do, more than one answer is possible. So I need to accept both from you. So let me explain. If you take a look at the first equation I wrote, the first function, because the x-intercept is negative 2.5, I wrote positive 2.5. However, you also know that if the binomial is 2x plus 5, and make that equal to a 0, 2x is negative 5, and therefore x is equal to negative 5 over 2, which is the same x-intercept. The reason why I wanted to show you both is because let's pretend, for whatever reason, I wanted to make this binomial look like the one above. How do I get 2x and turn it into an x? Or factor out a 2. So if I factor out a 2, this becomes 2 and then x plus 2.5. You see what I just did? So what is the difference from the people who get an answer for A here versus an answer for A here? Yes. So let's pretend your answer for A after you calculated was 2, right? For the people who went this way, your A value will be a 1. And I would have to accept both.
So the first one's right too.
So either one is okay because they both have an x-intercept of. Okay, let's see.
So why would you do the second one? Just like more like.
Well, depending on your habit, if you sort of humored me since chapter 1 and stuck with an x value with ax minus b form instead of dealing with decimals, then you would have written it like this, right? And then some people would write it like this, and then your A values would be different, and you'd be like, what the heck, did we get something wrong? Blah, 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 right? Why is our A value different? Okay, so I'm gonna do it both ways to try to show you that I would be happy to accept both answers. Yep.
Like the 2 is.
Give me a second. So let's pretend I'll color this one in blue. Let's pretend I did it this way, right? I didn't want to make any mistakes because I was scared that I was going to write this wrong. My y-intercept is 0, negative 2.25. So negative 2.25 is equal to a times 0 plus 2.5. And then 0 minus 3 cubed, which is negative 27 times that. Ooh. Negative 27, 27, 54, 27, 54 plus 13.5. 67.5. And so A is negative 2.25 over negative 67.5. So I'm going to have to reduce that. I'm pretty sure it's reducible. I can't do that in my head. Thanks, Michelle. Are you doing this or are you doing this?
Oh, no, I'll let you try it. 1/30.
1 over 30. Thank you. All right. Okay. So if this bracket had an x plus 2 is 2.5, and the a value is 1 over 30. And let's try the other way. If I happen to write out my zeros in this form, negative, I'll use a different color. I'll use green. Over here. It's the only other point that they give you, so you have to use it. Yes, Maggie? It's my bad. Sorry. Help me sooner. I am here for your comfort and your school needs. Okay. Let's try this. A, that would be a 0 times 2. That's a 0 plus 5. 5. And 0 minus 3 there. I know. I'm just trying to show you that if I didn't factor out the 2, even if I didn't, you'll see. Yep. Yep. Because factoring doesn't change anything in the equation. It just makes it look different. So the values, the math should still work out. So that is a times, so it's 27, negative 27 times a 5, 100, 130. Okay. So a is equal to, which is actually double 67.5. So I know I'm doing it right. This is going to be positive 1 over 60. So it only makes it hard for me on a test. If you wrote it this way, it is because your a value, you already took the 2 out. So I need to keep that into consideration. Both answers will be acceptable. So if you typed in 1 over 30 with an x plus 2.5, right, in Desmos, or you wrote 1 over 60, 2x plus 5 cubed, you get the same curve. Exact same curve. Okay. Which brings me to the final example. What do you do when the question gives you roots? Nothing different. Nothing different. I will try to sort of dismantle it for you, and then I want you to try example 2 on your own. Okay. Yes, it's annoying because it's got roots in it. So your calculations might be a little bit more. It'll take more time maybe, but it still shouldn't be a mystery. It should just be a little annoying. Here we go. I'm going to clear 1, 2, 3. All right. Plus minus 1 means my x-intercepts are 1, negative 1, 2 plus root 3, and 2 minus root 3. So what would the family of functions look like? Oh, I might need more space here. This is going to be x minus 1, x plus 1. And then, here we go. It's going to be x minus your root. Right? It's the whole thing. This entire thing is being subtracted. So this would be x minus 2 minus root 3. Let me write it clear. Okay, some people are squinting back there, so. Okay. Well, it's not simplified. I'm just going to multiply this out. So this becomes -2 minus root 3, and this becomes -2 plus root 3. But it is what it is, right? This tells you when the x value is going to be a 0. And it might look funny, but to me, it's perfectly fine. It says what it needs to be said. This is it. Okay. Let's see. Negative x.
How do you, when it was like 2x plus 3, what is it? X minus 2 minus root 3.
2x plus 3.
That's like 2x like root plus 2 plus root 3.
What about it? Why did I turn it into this? Well, you know how there's all these brackets inside?
Yeah.
I took that -1 and simply just multiplied it out so that we can get rid of that bracket and turn it into just one number, one term, one sort of, I guess, bracket. And again, this was just to sort of simplify it and get rid of some of the brackets to, clean it up, so to speak. Part B says I have a y-intercept at 5. Yeah. So I am going to say the y value is a 5 from when x value is a 0. So 0 minus 1 is a -1. Of course, y-intercept, it's not even assumed. If it says that the y-intercept is a 5, the x value must be a 0. That's a 1. 0 minus 2 minus root 3. So it's a minus root 2 root 3. And then 0 minus 2 plus root 3 is minus 2 plus root 3. And all you've got left is multiplying. So let me multiply the ones just to get that out of the way. And then this is distributive property. -2 times, here, let me color coordinate it. -2 times -3, and then -2 times positive root 3. They do. That's the beauty of this. So why you don't have to be worried. And then second part, negative root 3 multiplied by -2, and then negative root 3 multiplied by positive root 3. Yes, which is, yeah. So this is the blue part. That's a positive 2 root 3. I need to erase this, don't I? And then root 3 times root 3, root 9, or it's a 3, so it's a -3. So -2 root 3, positive 2 root 3, the exact same values. I'm running out of space because I'm writing so big. 5 equals a times -1, so a is equal to -5. Did I do something wrong? So I wanted to give you an example too, because I didn't want you to fear or be shaken up by a root. When you actually multiply it out, usually in cases like this, it becomes nice. Okay, it sort of disappears and you won't have to worry about it too often. Not always, of course, but typically in questions like this, it definitely will. So that's pretty much it. Family of functions simply means, hey, give me a generic equation with an a value. From there, if I give you a single point, can you find me the exact equation I am on, the exact curve I am on? Question.
In grade 11, we learned a bunch of like how to deal with roots and multiplying, dividing, adding and stuff. Are we gonna have to do that?
Deal with roots by multiplying, dividing, adding.
Just like root.
It may be a technique that comes useful. Please remind me later if you see it, so I know exactly what you mean. But wait, what? Oh, getting rid of roots? Oh, for the test, you have my guarantee. I don't think, I'm 99.9% sure I did not put any roots in the test. Okay, but again, just as I always say, you need to, don't run from it. Okay, in the future, I might throw it in, right? Just because I think you should be able to handle it. So again, the textbook questions that I assigned down here, they have a lot of examples of roots having, like factors having roots. Okay, so try them. Question 8.
What part of the chapter on the
Everything we've covered. So all of chapter 2, no 2.5. Anyone else? Okay, I'm gonna. Pardon? Yeah. So I'll say this one thing. If you remember that assignment that I gave you, without the substitution and elimination portion, everything else should have been smooth sailing. If that was a question on a test where you had to tell me the factors, find a factor that works, and then divide it, and then give me the final answer, that would be like maybe a 3 or 4 mark question. If something like that was on, not elimination, but I give you a polynomial and you have to factor it like straight without any help.
Like not the ones with the two variables.
Not the ones with 2 variables, but
So we have.
yeah, so you have an entire equation, and then I just say factor. I throw you in the deep end, just say, just you go in a factor. Questions like that. Dude, do the textbook questions. There's some good ones in there. Okay, how about I will go through the textbook and I will assign some good ones that you can try to feel better about yourself. All right. But all the homework that I give you is practice for that. Here we go. Last thing I want to say. I want you to know that you do, the test is, I believe, I think I gave a bit more than 50 minutes with the other class. So but it's supposed to be a 50-minute test. Time and a half means those people with time and a half will get an hour and 15. So tomorrow, to get that hour and 15, we need to start at 10:15. And I'm not sure how many people are willing to go for a walk just before a test. So here's what I will do as a promise.
Wait, something we get to have some time to review before the test?
Yeah, give me a second. In case I made a terrible mistake, I'm going to just double check my own personal schedule. So you did the assignment for me. Yep. Right. So luckily we were able to get through inequalities pretty easily on Wednesday. So that's why today is a lot lighter. Okay. Listen up. People in the back. People in the back? Over here, please. So this is my schedule. I am going to start our test with the extra time people right away at 10:15 and probably a little after 10:30, like pretty much at 10:30. I'm going to just get everyone started. I don't want to like, it's my personal laziness. I don't want to just like sit there and try to make sure I start exactly at 10:40. It's just annoying for me. Let's get everyone started. But yeah, a hard cutoff at 11:30. Everyone should be able to hand in their test to me. Is it long? Depends on how quickly you factor. And I'll give you my promise. I'm not going to do like my teacher did to me, where I give you a huge number and you have to test like 10 numbers before you find something. Okay. However, whether it's a integer or a fraction, that you should be comfortable with when you factor. Yes, you. The number of questions isn't much different from our mini test, but no, the mini test from chapter 1. But it is because I don't want scrap paper and I want everyone to show their work on the piece of paper. I believe it's 3 pieces of paper back and forth. Right? There are some multiple choice questions. Questions that are worth 1 mark. So it's not extensive. It's really just one shot. Do you know how to do it, or are you going to waste time? Case in point, know that multiple choice, there are certain skills that you can develop for multiple choice. Universities love multiple choice because it's easier to mark. And lastly, high school, we do try to make sure multiple choice questions are just one set questions. However, depending on what the question is on, if you don't know that one set, sometimes because you forget that one set, you may resort to multiple steps. Multiple choice questions are meant to be time killers. So, and it's only worth 1 mark. People who do not manage their time, right? It's a really important point to bring up, will waste too much time on the multiple choice. So, do that as it may. How you do your tests, you know the strategy that worked for you. I was one to start from start to finish. I was a little OCD that way. I just didn't want to skip a question and go to the ones that I knew how to do. Other people, they would rather save their brain power and energy by doing all the ones that they know how to do very easily, and then go to the harder ones later on. Do what works for you.
I started at the back.
It's like the harder. Yeah, they're worth more marks. Yeah, absolutely. Everyone's got their own thing. Do what works for you. The rest of the time is yours to use. If you want to study here, practice test questions on textbook. I'll find some textbooks for you as textbook questions for you as well. Study sheet, big thing. And one last thing, if you remember my little announcements, I told you not to forget, because it is part of chapter 2. Don't forget restrictions. Don't forget what it means to do a division versus a quotient statement. Just write down, a simple example on your study sheet. Sum and difference of cubes. It's not going to be extensive, but if I give you a cubic, like some kind of cubic plus a cube, you should know how to factor that. That could be an easy multiple choice question. You see what I mean? Yeah. Yeah, it's like 9a cubed minus, 8a cubed minus 64b cubed, right? Being able to use the formula and just factor it in one step. And proper interval notations, the ones with the brackets, union bracket thing, that might become very useful to you as well. Okay. Yes, May?
Are there any explaining?
There will always be a little bit. There aren't too many, but yeah, communication, as long as you get to me, whether through diagram or through example, if your explanation is clear, you get your marks. So whatever you need to. Yes.
Is there gonna be any questions like the one, like the original?
Original equation.
Like where you don't have A or B?
Oh, well, you know what? Some of the textbook questions do give you one unknown,
Yeah.
right? They're like, what is the K value if this has a remainder of 2?
Yeah.
Right? Those are okay, but I won't get you to do substitution elimination, I think. Yeah. Or I won't, period. Yeah. No, okay. I'm gonna sift through the textbook to see what other questions might be useful for you in preparation. I'll choose some of the harder ones to really challenge you. Everyone else, use this time wisely. Yes, Anders? Yeah, well, just go for a short walk. We will go for an outside walk at 10:15. Really? Okay, come back quickly. Okay.
That for me.
They should. They should. There you go. Big smile. I love it.
I don't think that, is that?
That is correct.
Oh, it is.
Yep. Keep going, and when you put in the calculator, it actually reduces to a next number.
Oh, okay. That's okay. I think about it. Thanks.
I had to ask you a question. I don't remember this, so I said it.
No problem.
Yeah. That's like right next to the door.
I do not.
You want to take a picture?
You know, thank you so much.
Okay, can I get like one? I get the right answer every single time.
Oh, yeah.